This is Cottam coal-fired power station in the Lower Trent Valley near Retford. The UK needs coal, and New Crofton Cooperative Colliery is designed to recover up to 4.9 million tonnes of coal over a 20-year period by means of a new underground drift mine. It has been established as a workers' cooperative which truly seeks to be part of the coalfield community in which it is situated. This presentation explains the need for coal and describes where and how the mine is going to be operated. Despite what people might like to think, coal is still the dominant fuel for electricity generation, generating over 40% of the UK's electricity, and it's likely to stay that way for some time yet. In fact, coal usage has increased in the last few years because of the diminishing UK supply and significant price rise in gas. Nuclear is also reducing due to old reactors being closed, and renewable sources are not growing at a particularly fast rate. Since 2003, coal imports have exceeded production, with nearly 50 million tonnes imported in 2013. That's despite the fact that in 2011, the Energy Minister stated there were over 3 billion tonnes of coal reserves left in the UK. Since 2006, more coal in the UK has been produced from surface mining than from deep mines. Both of these facts would have been unthinkable 20 years ago, but we are now reduced to just 3 deep mines of any size, and 2 of those are scheduled for closure by the end of 2015. So with that as the backdrop, let me introduce you to New Crofton Cooperative Colliery, a brand new drift mine in West Yorkshire. The site lies approximately 7 kilometres southeast of the centre of Wakefield, roughly equidistant from the M1 to the west, the A1 to the east, and the M62 to the north. This places it in the heart of an historic coal mining community. Importantly, the site lies immediately adjacent to the Wakefield-Doncaster section of the main Leeds to London Railway. Here you see the site adjacent to the railway line, with evidence of underground and open-cast mining around. To the west is Anglers Country Park, a restored open-cast coal site. To the east was Nostell Colliery, later to become Long Row open-cast coal site, and northeast of that, close to Nostell Priory, is the Nostell Brickworks and associated clay pits. The closest properties to the site are in the south-east corner of New Crofton, approximately 550 metres distant. This aerial overlay of the previous map shows the mainly agricultural use of the surrounding area. Here we see the site's long association with mining. The white structure in the middle is a large bunker for loading coal onto merry-go-round coal trains, as this was a disposal point for coal extracted from various open-cast coal sites, including Anglers and Long Row. One of the main benefits of this project is that although the bunker has now gone, the sidings, points and signals are still there and in working order. This means the colliery will be able to send out most of its coal by rail to any of the coal-fired power stations in the north of England. Up to 15% of the coal produced will be of sufficient quality for use as domestic heating fuel and for the steam heritage market, and this will be dispatched by road. Some years later we see the bunker has gone, but the site is still being used for processing and loading material from the Moorhouse coal and fireclay site just to the south. And this shows what the area looks like now from the air. So where will the colliery actually be? The green dashed line shows the colliery curtilage, which is just 3.7 hectares, with another 1.3 hectares in the red extension forming the access road to Santingley Lane to the west. The blue line indicates the area for which we have a lease agreement with the owner, Harworth Estates. This plan puts the site into a geological context and shows the extent of the underground workings in pink. a total of 174 hectares or 430 acres stretching approximately 2 kilometres north to south and east to west. It also shows the two major faults in the area and how the Rye Hill fault forms the southeast boundary of the mine. So let's have a look at the seams we're interested in, which are part of the middle coal measures in the Upper Carboniferous. The British Geological Survey's generalised section is on the right, and on the left is the old National Coal Board specific section, showing the 4 Charleston seams which we will take: Charleston Top, Charleston Muck and Low taken together, and the Charleston Yard. These range in thickness from 0.7 to 1.6 metres, and some are split into 2 or more leaves. The specific section also shows that the separation between the top and bottom seams is on average 41 metres. This shows the previous open cast sites which surround the mine area, shown in pink, and indicates the location of the faults which cut through the mine. Most of the borehole data was collected by British Coal when they were planning for an open cast site. In the end they decided just to take a small area near the surface known as Morehouse Site. Now for the first time we get an idea of how deep the seams are. The left of this section is close to the shallowest coal we want to mine, which is 50 metres deep, and on the right we can see that the Charleston Yard is nearly 160 metres below the surface. The fault running through the middle of the colliery has a down throw of 50 metres to the southeast, causing the Charleston Top in the south to line up almost perfectly with the Charleston Yard to the north. The drifts themselves will be 5.5 metres wide, 2.2 metres high, and have a 1 in 4, 25% or 14-degree decline. The upcast drift will contain the conveyor and will also have 2 coal bunkers cut into the rock above it. These will be able to load onto a second conveyor mounted above the main one in order to load into the coal wagons when required. Now we move on to the mining method, which is called room and pillar or pillar and stall. The coal is recovered from the rooms or stalls, leaving the pillars in place to prevent the roof collapsing. The pillars here are rectangular, but in our mine they will be 10 metres square, with roads which are 6 metres wide, and this will give a coal recovery of about 55%. Coal is extracted from the rooms using a continuous miner, which is able to work in seams as low as 3 feet or 90 centimetres. The machine has a cutting width of 3.4 metres, so we'll be able to develop a 6-metre wide room in 2 passes. In the diagram, the coal is being loaded into shuttle cars, but we will use battery-powered coal scoops to move the coal from the continuous miner to the feeder breaker. Here the scoop is being used for ancillary tasks. Once at the feeder breaker, the coal is broken into fragments smaller than 15 centimetres so that it can easily be transported on the conveyor to the surface. After the continuous miner has cut a room to the required width and depth, it will withdraw to work on another room, allowing the roof bolter to enter and insert resin-bonded steel roof bolts to secure the roof. Finally, we will use the same 5-road entry system for the main drivages that we see here. This is what the configuration of rooms and pillars looks like in the northern area of the Charleston Top seam. Remember, the pillars are 10 metres by 10 metres. The pit bottom area is shown here in green, approximately 50 metres below the surface. The permanent barriers between the working districts are also shown in green. The main access drivages are shown in yellow, and the production districts are blue. This is an example of how the rooms would be developed in a 4-room entry system. In fact, we will use a 5-room entry for the main access drivages and 7-room entry for the production districts. The continuous miner will drive forward, forming the road in 2 passes. It will then relocate to start another room, giving the roof bolter access to secure the roof. When this is complete, the continuous miner will return to continue driving forward, while the roof bolter moves to the new room that has just been created. In this way, the rooms will advance, until all the rooms have been driven far enough into the seam to allow the crosscuts to be created. This animation shows how the 5-room main drivage is extended and how the 7-room production districts are then opened up. What wasn't shown in the previous slide was that 2 of the roads being driven forward will be enlarged to a height of 2 meters to make room for the conveyor and allow a ventilation circuit to be established along these oversized rooms. The feeder breaker, shown in red, is repositioned at various times, with the conveyor, shown in blue, being extended behind it. This will continue until the required length of the development drive has been reached, at which point the equipment will start to work into the main 7-room production districts as shown. This is the same area and seam as shown before, the Charleston Top northern area, and demonstrates how it will be worked over a period of 12 months. The solid barriers, shown in green, are there to divide the seam into working districts and assist with the roof support and the ventilation flow. The 1 in 30 dip to the northeast explains why we will start coaling in the east. The development of the Charleston Top seam in the southern area is similar in style to the northern area. We can see how there is no mining underneath the local villages and farms, and recovery is reduced below potentially sensitive areas such as the roads by reducing the number of rooms. We have demonstrated a safe and economic method of working these Crofton reserves. We believe that similar mines could be developed in the many remaining areas of unworked lower height coal which remain in the UK, helping to keep the lights on and providing much needed investment and employment in UK coalfields.